Given this integration question, so let's cycle through the sorts of methods we might use for it. It's not a standard integral. We can't expand this or anything in any way. That would be an infinite expansion. It's not like a trig integral or anything. It's not reverse chain rule where we can kind of see the derivative is here and something on the inside is here. Like if there was an x squared there, actually that would be the case. It is a product, okay? So it's worth thinking about the fact that it might be integration by parts, or maybe we could do some other substitution. And actually, in this case, I think we could do either of those two methods. The one that jumps out to me is to do integration by parts. So I'm going to start with that method, but I'll also show how substitution would work. So show that question so we know at the end of the day what the answer is going to be. Okay, so integration by parts. Right, well, we can write down a little acronym LATE to tell us what to let u equal. Logs goes first if ever you have a log, then it's algebra, then trig, then exponential. To be honest, in A level, you're expecting to use one of these two, I'd say. Um, so there's no logs, so I'm going to let the algebra be the u. Okay, there's two bits of algebra, but it's going to be the simplest one. So, because when I differentiate that, it's just going to become 2, which makes it much easier. If I differentiate the other one, it would actually still be quite complicated. So you've got u and v dash, then u dash will be 2. Okay, v dash is actually x plus 2 to the half. So that means v, I need to integrate it. So I'm going to raise the power by 1 and divide by the new power. So actually I'll be times them by 2/3. I don't need to divide by, this is actually an f of ax plus b kind of derivative, we might say. So then you divide by a when you integrate, but in this case it's just 1. So actually that is our integral of it, and you could check it by using a chain rule to differentiate it back. Right, we're off, we're ready to go. So the integral, which I'm going to say is I, define it as I, is going to be, this is in the formula book, uv minus the integral of u dash v dx. Okay, in our case, we've also got the limits between 0 and 2. So u is 2x, v is 2/3 times x plus 2 to the 3 over 2. Okay, so in a minute we can evaluate that one. And I'm minusing the integral of u dash, which is 2, and times the same thing. I'll just tidy this one up. It's going to become 4 over 3x. I'll substitute in on my next line. And then I'm minusing. Do you know what? I'm going to go straight for it here. So I can, 2 times 2/3 is just going to become 4/3. Right, so I'm going to get 4/3. That just carries on through. And then let's integrate x plus 2 to the 3 over 2. It's a bit like when I integrated x plus 2 to the half. I'm going to raise the power by 1, divide by the new power. Okay, and nothing coming from the inside here. So that's it. That's why integration by parts is working really well, because that second integral wasn't too bad to do. So I'm just going to tidy up this bracket here. I'm going to get 8 over 15 actually when I do 4 over 3 times 2/5. So let me change it to that. Okay, let's sub in. So I'm going to get 4 over 3 times 2 times 4 to the 3 over 2. Then minus actually 0 because I've got an x there. Just be careful. It's not always going to be 0 if you have exponentials, for example, but it will be here actually. Not actually sure I'll put that in a square bracket. I'm going to get rid of it. Then I'm minusing 8 over 15 times 4 to the 5 over 2 minus, okay, now I'm going to put another bracket in because I'm minusing the whole thing. Right, yeah, this is why I need to put 0 in here, because I'm going to get 8 over 15 times 2 to the 5 over 2. Let me just, sorry, I didn't quite leave enough space. Okay, so I get 8 over 3, 4 over 3 times 2. Then 4 to the 3 over 2, you can put it in your calculator, but actually you can do the square root of 4, then which is 2, then cube it, we're going to get 8. then minus 8 over 15 times square root of 4 is 2, then cube that, I'm actually going to get 32. But you can, of course, just do 4 to the 5 over 2. And then I'm going to be plussing, because it's like a double negative, 8 over 15 times 2 to the 5 over 2. That's the most awkward bit. You can actually use your calculator to help you, but if you write 2 to the 5 over 2 in, it will just write it as a decimal. So you have to at least do, I'm saying if you're struggling with this kind of thing, you have to at least do one little step and write it as root 2 to the 5. Then your calculator can actually deal with that because it kind of it recognizes now that it's, yeah, root 2. It doesn't before. Then, oh no, I'm sure I've had it working before. Okay, you can deal with root 2 cubed, but not root 2 to the 5. So yeah, okay, we're going to have to do it a different way. So it's actually root 2 times root 2 times root 2, like 5 times. So when you do root 2 times root 2 times root 2, you just get 2 root 2, as my calculator shows. If I times by root 2 another 2 times, I'm actually going to get 4 root 2. This here is 4 root 2. Okay, this is looking good now because I've just got fractions and I've got a root 2 there. Now, for the next bit, you can either try and combine these terms by hand and maybe look for the 32 over 15 to factorize out. That's actually what I did originally when I did this question. Or to make life a little bit easier, just put the first two terms in your calculator. You get 64 over 15. Because we're actually really, look, you can actually see that's there, okay, when you times that out. So that's really good. And then I'm going to have plus, well, it's 4. Actually, to be honest, we can just put that in as well. So 8 over 15 times 4 root 2 becomes 32 root 2 over 15. Okay, we're one step away. I can now factorize out the 32 over 15 as they've done in the final answer. That's going to leave me a 2 here, get my 64 over 15, and then I'm just going to be adding root 2, which is what we're after. So we're pretty happy with that. So yeah, integration by parts, it works out okay. Just deal with the fractions carefully, substitute in. The most awkward bit is this bit here that your calculator can't deal with. So make sure you learn how to deal with surds and so on. You can use your calculator to help you to some extent. Bring it together and we've got our answer. Just leaves my second method of substitution. Let's see how that works. Okay, probably a bit more awkward unless you're really happy with your substitutions. So I'm going to let u equal x plus 2. And the reason I know to do this is that I'm going to then make it u to the half. It's going to be much easier to deal with. Du by dx is then equal to 1. And then it's up to you. You can either write dx equals dx by du. Oh yeah, and which it is also 1 by swapping it around. Du, that's kind of how I do it, using this actually is the chain rule. Or you might be somebody who likes to write dx in terms of du. Okay, in any case, we're just basically going to be able to swap it all around. And then x is going to be u minus 2. So 2 u minus 2 times, it'll be the root u, or u to the half, du. Just need to change the limits. So when x is 1, sorry, x is 0 rather, u is just going to be, it's x plus 2, so it's going to be 2. And when when x is 2, u is going to be 4. Okay, so I get 2 and 4 here. I can expand out this integral. I'm going to get 2u to the 3 over 2 minus 4u to the half. So I've avoided integration by parts. I've got these to integrate, which are a little bit nicer. I've had to do this substitution now. So raise the power by 1, divide by the new power, 2 times by 2 over 5. So I'm going to get 4 over 5 here. Similar over here, we'll get 3 over 2 times by 2/3. That's going to be 8 over 3. And substitute in. So 4/5 times 4 to the 5 over 2. You can see similar things happening to before. 8/3 times 4 to the 3 over 2 minus 4/5 times 2 to the 5 over 2 minus 8/3 times 2 to the 3 over 2. This again becomes 32. This bit here is 8/3 times 8. My 2 to the 5 over 2 as before is 4√2. And I'll end up plussing 8/3 times 2√2. Bring this together, so 4/5 times 32 minus 8/3 times 8 gives me 64 over 15 as before. Then I've got minus 4/5 times 4√2. Oh, make sure it's outside of the root, plus 8/3 times √2, which is, I've made a mistake there somehow. Just double check it. Minus 4/5 times 4√2 plus 8/3 times, 2√2. Okay, that's better. 32√2 over 15. And we can again factorize out that 32 over 15, leaving us 2 plus √2. All right. I don't know if there's much in it really, which is the best method to use. I'd probably say integration by parts is kind of the one that jumps to mind more, but substitution works as long, I'd say become familiar with both. And as you practice your integration, you kind of learn there's more than one way to do something sometimes. Sometimes there's more effort to do it a certain way. Sometimes it's about equal. Anyway, well done on this question.